good morning, good evening, wherever you are. Welcome to, I guess we'll call this the Enterprise Kubernetes Studios, Enterprise Kubernetes, the massive Enterprise Kubernetes Studios. Um, my name is Mark Borstein, CTO at Tremolo Security and co-author of Kubernetes and Enterprise Guide. Scott Sorovich joins me. You want to introduce yourself, Scott?
Sure. Scott Srovich. I'm a principal engineer at a very large global tier one bank.
Yeah, it works for me. We are going to be discussing black magic today, voodoo, networking, right? So like this is one of the fun parts to me about this book and being able to work with you, Scott, on this book is I don't come from the infrastructure side of the book. I come from the application development side of the book. So I'm the annoying guy who's just like, this should just like work, right? Like just give me a host name. Give me an IP, whatever. Like I just need a bit. It's just a bit. That takes like 10 seconds, right, Scott? I mean, that doesn't take any time at all. That's easy. What's taking so long? Come on, let's go. So reading this chapter was like, and I've got a degree in computer science. I've taken classes on the mathematics of how IPv4 addresses are calculated and whatnot. And not that I remember much of it, but yeah, again, I know enough to be really, really dangerous when it comes to network design. And what was amazing to me about this chapter was just like, oh, I can do that? That's all I gotta do? Really? And like it just worked. And so like even before we hopped on the stream, we were talking. I'm rebuilding my lab at home and just like adding MetalLB, which I think that's in this chapter, right? That's not.
It is. Yep.
It's just magic. Like I have a load balancer. I didn't have to add like a NIC or like do anything weird. So I was just like, oh, there it is, just work. So we're talking about chapter 4 of Kubernetes Enterprise Guide, 3rd edition. So we're talking about services, load balancing, and network policies. Unlike our previous 2 chapters, we're probably going to not spend a lot of time chit-chatting, if for only reason is that we have a lot more labs in this one. I think the first 2 chapters, we only had about 5 minutes worth of real labs. This one we get down and dirty real quick. But please leave a comment, say hello, ask a question. We'll do our best to get back to you during the stream, and if we don't, we'll try and follow up afterwards. So I'm going to shut up now and let you take the reins because this chapter is your baby.
Yeah, it's actually one of the first chapters I wrote even in the 1st edition, just because heck, you need services. Right, so we go over the chapter, and I'll never forget, 6-7 years ago, say about 7 years ago, even looking at Kubernetes to understanding, in VMs, you deploy a VM, you tie it to your virtual switch, and you can connect to everything. You're like, this is cool, great. Deploy a pod, and you're like, cool, I want to connect to MySQL. And you're like, what do you mean? I can't hit it. What's going on? It's running, pod's sitting there. Why can't I connect to it? And of course, you realize, as you learn this, and again, you went back time, right, Mark? You come from the old days, right? Early, probably better term. And there just wasn't a lot to read on.
Getting older by the minute, Scott.
It's absolutely, that means closer to retirement, but let's not go there. So, you start reading about services, right? And that's what we'll kind of get into talking about this. And of course, lots of different types. As you said, there's networking considerations, right? I made a meme about this, and I showed it to you once, right? Kind of Star Wars. It was about somebody saying, hey, I deployed Postgres, MySQL, something like that. I created an Ingress rule. I put the service in. I can't connect to it. And it's like, yeah, that's not how it works. You're talking about layers in the OSI model, right? And I know it's old school, but OSI is still relevant, right? Because you're going to hear terms, layer 3, layer 4, layer 7. Of course, you got the DoD model, which shortens it to 4, right? But we're going to talk 7-layer OSI model. We don't dwell into it. I mean, it can be, again, going back to the old days when I taught Novell had a 3-day on just OSI model. I mean, mind-melting, boring, to be honest, right? Because it's a lot to do. But man, you knew the OSI coming out of it. So we'll focus on this one where we're going to go into like layer 4, layer 7. Going to my meme example, well, it's layer 4 traffic, right? You're not coming through layer 7 at the top of the model, and that's just something we're not going to get into it too deep, on this call. But I encourage anybody to go take a look at the 7-layer model, right? And knowing application layer and coming all the way down. The way to remember it is, on the fly, I'm going to try this. It's like, please excuse my dear Aunt Sally. I'm trying to remember the first letters. And that's how you remember the 7 layers: presentation layer, data link layer, and, going all the way up. So we'll get into that a bit, and that's where we deal with ingress rules, for an example. Now, I don't want to get into that on this session, but people are going to say, well, yeah, but something like NGINX can do layer 4. It can, not quite like MetalLB or a load balancer, right? There's a lot of configuration in that. So we'll talk about.
Well, and I and I do this a lot. Like I do things on the cheap, right? Like I do a lot of single VM clusters where the master also runs NGINX, right? And so I'll use something like a host control. But yeah, I mean, you can do it with NGINX, but you're not, you're not getting, one, it's pain to manage because you got to do it at the command line. It's not, and two, you're not getting any of the benefits there. Like I feel like there are probably a lot of benefits to using something like MetalLB, even beyond the fact that it's easy. Like I was saying this earlier before we hopped on live. Being an applications guy who only knows enough about networking to be super dangerous, the fact that like I was able to take the examples at the back of this book, get them up and running, and for a home lab, the layer 2 speaker stuff is like perfect, right? I have IPs. I made sure that my DHCP isn't handing them out. I know people are going to yell at me, don't overlap DHCP and static IPs, and sorry, not sorry. But like, the fact that just worked was just like, my mind was blown. I had a Helm deployment, a pool, and a speaker. 3 things that I added to my cluster, and now I'm able to actually generate load balancer IPs that I can then assign to my NGINX, and it makes configuring the clusters so much easier. So real quick, we've got a question here from Kafka. By the way, thank you for coming on, Kafka, and saying hi. Can we provision the ingress controller for K8s other than NGINX, such as HA proxy? How many alternatives in this regard? There are a lot.
Yeah, so I'm following the question. Provision the ingress controller other than NGINX. Oh, so you want to replace it?
I'm thinking like, what are the alternatives to Ingress-NGINX for? I mean, real quick before we get too deep, one of the things that for people to remember about Ingress in general is that the Ingress API is a way to configure a reverse proxy. Like that's really what we mean by Ingress. So when you deploy an Ingress, and we'll get into this when we get to the example in the chapter, like NGINX, it's just an NGINX pod. What makes it an Ingress-NGINX, an Ingress controller, is that Ingress object. It's watching changes to that Ingress object. It's basically an operator before operators were a thing, right? It's watching that Ingress object. So when you make a configuration change, instead of going in and configuring NGINX for whatever you want, it's translating, the controller is translating that NGINX, that Ingress configuration into a NGINX configuration. That's all an operator, or that's all an Ingress controller is. So any web server could be an Ingress controller, right?
Right. So, and outside of Kubernetes, right, you see Apache a lot for that, right, Mark? you see Apache being used a lot in something like that.
Do you still see a lot of Apache? I have not seen Apache
external.
in a long time.
Yeah, typically NGINX is really the big one, right? You do still see that. Not Ingress controller, but NGINX.
Right, like the actual NGINX web server.
Yeah.
I don't run into a lot of Apache. I think IIS is dead too, isn't it? Except for like legacy.
Well, if you're on Windows, it does a pretty decent job with that still. It's pretty heavily used still, internal at a lot of places, right? That's where I see it more. But not typically for that use case. It's more specialized use cases. But on to that question, make sure we address that question first. Is there's the other popular option, right, Mark, and you've probably seen this too, is Envoy. You'll see that in a lot of clusters, traffic. Specifically on HA proxy, yes. When I started, again, going back, they didn't have one. It's been a long time they have had one, but there is an HA proxy ingress controller. So different from the HA proxy load balancer that we've mentioned in the past about being a front end to go over. So why do I even bring that up? So typically, of course, on a cluster, you're going to want more than one replica, right, of your ingress controller. So, at least 3, 5, whatever you're going to pick, right? I mean, I'm not going to tell anybody what they should, but minimum of 3. That's on 3 nodes. So how do you load balance between those? So you're still going to have some kind of a load balancer. It could be MetalLB, but it could be HA proxy as well, externally F5, enterprise, and all that, of course. But yeah, which one's better? That's and I used this before on the call, right? It's like walking into a comic book store and saying, what's better, DC or Marvel? You're going to get some interesting conversations going, a little brawl, probably. I'm a fan of.
Okay, you can like DC more. You just be wrong.
Yeah, there we go. We can start that conversation. I'm in agreement, so I wouldn't even argue that one. But so they all have different types of features, right? The one thing about NGINX I really like is annotations, right? The customizations you can do. Envoy has a limited set versus that.
When you say Envoy as a ingress controller, are you talking about an actual project called Envoy Ingress Controller? Or are you talking about one of the myriad of program controllers that use Envoy? Because like Kong uses Envoy, Istio uses Envoy. I think there are probably some more that use Envoy as their Cilium uses ingress controller, uses Envoy.
It does. So yeah, you're right. If you're going to deploy it yourself, you probably wouldn't use those, right? You're not going to deploy Kong for that, or even Istio, right? Well, you might if you want a service mesh, which we'll do, of course, later on in chapters, because it can serve as a normal ingress controller. Typically, when I see Envoy with Istio, right, you're doing Istio native, resources like the virtual services and the gateways and that. So, but it does serve as an ingress. So yes, I'm referring to just deploying it as a normal ingress controller. But it has some limitations on customizations of your rules, right? And I'm not going to pretend I know all of them. But if you ever check out the NGINX documentation, it's just pages and pages, right, of what you can set, whether it's pass-through, whether it's header sizes, you name it, pretty powerful. Oh, yeah. Alan's mentioning Contour, absolutely. Another
Contour,
one. Yep. Yeah, I see it, I don't say often, but I say the big 3 is you'll see NGINX, you'll see Envoy, and you'll see Contour. And I do see traffic, from time to time. It's always, pick whatever or whatever the vendor supplies. Now, of course, let's not get into the conversation on cloud providers too. That's another can of worms.
And something to point out about cloud providers though is a lot of cloud providers will let you either bring your own ingress controller, or they often have their own ingress controller for their built-in load balancers. So you can, like in AWS, I've got users of OpenUnison that do this, that will define a ingress that just deploys a load balancer for AWS, an AWS application load balancer. Same thing with Azure. Although Azure uses its application gateways. Those are much heavier. So I actually don't run into a lot of people that use those as ingress controllers. But yeah, so it doesn't have to run in cluster for it to be a ingress controller. Just the part that listens for the ingress objects. But the web server itself doesn't have to run in cluster. I'll be honest, my first go-to is still Ingress-NGINX. It's, especially if you're a beginner, because it does the most things the most easily. Like, I don't know that it would be my go-to for every production deployment, and there are a lot of good reasons to use other implementations. But for me, at least, the stuff I do, I find NGINX is just the easiest way to get started if you don't want to, if you don't want to get bogged down in figuring out an ingress controller. But, like Contour, as an example, if you're running the Tanzu stack, you're going to be running Contour, right? So a lot of times those stacks will come with their own chosen ingress controller.
Well, like Anthos actually includes Envoy, because they include Istio as well. So they kind of piggyback on that, saying, you know what, we've already got Envoy here, so they just have a ingress class for Envoy, and it works perfectly well for what it's doing.
Awesome. I don't know what's going on with LinkedIn. I gotta see if maybe we're not properly, because we're clearly getting people from LinkedIn, but we don't know who you are and we can't see who's.
Sure, this is LinkedIn. Yeah, it's okay.
Yeah. So
that's
you
interesting.
Want to talk about this one a little bit?
Well,
I know this, but I'll
going to say
if
it's zero trust, that's going into Mark's wheelhouse. But getting into network policies, which is actually at the end of this chapter, I think, a little bit of it. That's not, to me, not zero trust. Portions are going to fill in a blank, right? But you're not going to check that box. You're going to get a sub checkbox, I'm going to call it, Mark, maybe, because what you're going to do with network policies is just kind of stop the traffic, right, or allow it, which is great, but that's just one thing. Now, the traffic that is allowed, where's the zero trust portion of that? So right. I think, and Mark, you want to get into that? I'm thinking identity and other things like workload identity potentially in that.
So yeah, I mean, zero trust, and there is no need to fear because Boris is here. My good friend Boris, who I met over at the ContainerCraft Discord. So good to see you, Boris. Thanks for coming to hang out and asking a great question. So zero trust is typically defined by identity, like you said, Scott, not by firewall rules. I think network policies kind of come into a bit of a gray area there.
Well, let's just a little bit there.
Defining it, so you're the network policy itself is not based on the identity of the pod, but you're not doing it purely based on ports either. So it's not zero trust in the sense that you're validating an identity, which would be really what the intent of zero trust is. There is an argument to be made that there is some zero trust application there because, we'll get into this when we get a little later in the chapter. Typical legacy firewall rules, I guess I'll call them. You say, all right, I'm only going to let you in if you're coming from this network, right, or from this host, or I'm going to open up these ports. And you can do that with the network policy, right? Like you can totally do that. But what is more common, or at least what the intent is, I would say more, is that you define labels of what you want to let in. And those labels are a way of providing an identity because you can track back the fact that that label had been set by something. So you are authorizing. So it's a little more roundabout, but I would argue network policies in certain circumstances kind of are in a gray area.
Well, and I'd probably specify with network policies too. We got to be careful because if you're dealing with native Kubernetes network policies, not Cilium, right, or an add-on like KubeArmor, you're dealing with a certain layer, in this case, layer 4, which means you don't have access to certain things that would be at layer 7 that could be useful for that. Now, that's why you do something like a Cilium policy, because certain CNIs in Kubernetes will enhance that.
What CNI mean, Scott?
Yeah, we did this. I think we mentioned it last week, right? But yes. The container networking interface. So it's your flavor of network support for your cluster, right? And a common one is Cilium, which is very powerful for that reason, right? It has its own service mesh. It has its own network policies. It still supports Kubernetes policies. It's a very cool CNI in my opinion, because of course, big buzz term right now, eBPF is how it really functions. That gets into a Linux kind of thing, but highly encourage anybody, if you don't know what eBPF is, to go take a look. There's somebody who works at Sysdig who wrote a book on it. It's the authoritative book. I apologize, I gotta look up the name. It's been a while, but it really does get into the eBPF, and that's just partly for networking, right? You got process. We'll do a lot with eBPF discussions in runtime security when we get to that. So yeah, we don't want to necessarily ruin that chapter yet.
And real quick question here: are all CNIs created equal? Like, is an IP address just an IP address? Is a cluster IP just an IP? If I deploy with good old-fashioned flannel, and I'm not referring to a pattern on a shirt, right? Or versus Cilium versus Calico, like what are the differences to me as a cluster operator when it comes to those different CNI implementations?
That's a good question, though. Actually, Morgan, I'm gonna be blunt. I haven't looked at flannel in 5 years, right? It just didn't meet what I wanted to play with. It's almost like saying, let's use NetBUI, instead of IP or something, because it's out there, it works. So fundamentally, you're still, every cluster is going to have its IPs, right? You're going to have your services and you're going to have your pods. So those CIDR ranges that you set during installation really are pretty much a Kubernetes construct, I want to call it. Now each CNI will handle traffic differently. So if we're talking about, encapsulation, if we're talking about eBPF, right, direct traffic routing, depending how you deploy some of these CNIs, heck, your pod may actually get a live layer 3 IP address, right? So you could actually hit the pod directly, or heck, services. That's where load balancer comes in. So I would say the fundamentals of the IP portion, pure high-level IP addresses, unless I'm missing something, because there are a lot of CNIs, right? They're pretty much the same. But how they function really can be different, right? Depending how it does routing, right? You have to use IP tables, for an example. Can you get away from that? No kube proxies, kind of do that layer out. And that's where I like Cilium. Big fan because of that. You can even take your CNIs like Calico is a good example, and you get in the networking, right? Everybody's apologies, but BGP peering, border gate protocol, where it routes are exchanged through peering. And these get in the conversations, honestly, and I'll be that honest, I did networking a long time ago with Cisco. You kind of got out of my realm quickly when you get into this now, because there's a skill. You just can't know it all. You can't remember all these networking and stuff, but enough to understand where I'm in conversations with networking about why I need BGP or why I would do it. But yeah, so I'm going to say high level for this conversation, IPs are there. The CIDRs are the same, right? You need IPs. You need IPs for your nodes too, right? But that gets into another other conversation. Banyan Vine.
Yeah.
I think even when that was out, nobody mentioned it.
Well, I don't even know, what is Banyan Vines?
Oh boy, it's just you're getting out of my realm a bit. I'm going to be dead honest, right? You're going into older technology, and as long as we're naming it, let's Token Ring, right?
I was going to say, is that like Token Ring? Because I know what that is.
Yeah, that's more like saying more than like Ethernet though. So I don't know if it's quite the same kind of conversation because now we're going from protocols
Yeah,
communication
yeah, and let's be real.
to yeah, because this can
Like,
really
is
get into the weeds.
there really any ring left? Like, that's not even one of those legacy
I don't
technologies.
think you can anymore.
Yeah,
Interesting when
like
you set it
it's not
up,
like
right?
COBOL or Fortran or
Oh
where
God,
it's like,
no.
oh, this system was written in the 50s and it
Yeah,
still
yeah.
runs, so we haven't touched it. I just don't think that hardware exists anymore.
Well. So
Um,
I hate to do this, but as much as it's great to get into those conversations, getting into these topics more, right, Mark? Because it's a long chapter. We know we're not going to finish all
yeah,
of it
and I was going to say, do we
today.
want to start diving into um, uh, uh, I know that there was one thing you wanted to show. Did you want to do that first, or do you want me
I
to dive into the
do
lab?
no. Let's do this part first. So what we'll talk
Okay.
about is
Why don't you drive?
we have of course services, right? Guys? So okay, let's go back to the beginning conversation. I deployed my pod, right? And I kept saying, okay, I want to connect to that. Okay, so when pods deploy, um, they don't register DNS names like you would think, right, in the real world. So on top of that, they're ephemeral, right? We always talk about ephemeral being temporary. So you run your pod, you delete it, you recreate it. There's a high likelihood it's got a new IP, right? And it could look pretty drastically different because of the way the CIDR ranges get broken up between nodes. And again, gets into a conversation that's just not really part of this chapter. So you never, I've seen it done, you never target the IP of a pod, right? It's heck, servers, you never target an IP. You shouldn't. I know there's rare occasions, let's not get into use cases, but you want something to be more stable, all right? So that's why we deal a lot with services in this chapter. And a service will give you a stable IP. Now, when we say stable, that's because they're not ephemeral, right? You don't see your services disappear unless you delete them, right? That's a different story.
Do the IPs associated with services stick around? Like, are those fairly stable, or because like I generally reference a service by name. I don't think I've ever referenced a service by IP, but are those IPs reliable?
It depends on the terminology you mean by reliable, right? So yeah, it's not going to change unless you delete it and potentially recreate it. Now, I've seen those usually get the same IP depending on the cluster. Let's be honest. You're in an enterprise and you've got hundreds of things happening constantly, right? Whether it's the ICDs, additions, deletions, and you do something and you recreate that service an hour later, you're probably not getting that IP, right? But it's always a question. And I've had people say that. Well, I deleted and recreated, it's the same. I went timing, right?
Yeah.
Lucky and timing. Like you can't assume that's always going to happen. So I tell this to a lot of new SREs, right? People, you see a problem with something in Kubernetes, a pod, crash looping, something. It's human nature, and people would just say, let's delete the pod. Well, that works okay in a respect, right? Because pods recreate. We know that.
Remember, SRE stands for simply restart everything.
Actually, I did not
We
know
send
that
all
reference.
complaints to
I like
somebody.
that. I like that. I like that. And I get it, right? That used to be the thing all the time. Reboot, right? Call your cable company if you're messing up.
Microsoft patch.
Unplug. Oh yeah, and it's so. But services don't always keep that in mind, right? You delete your service, you're going to go, why didn't it recreate? Yeah, it's a deployment model. It doesn't do that. So, but you're always going to upgrade your pod. You rarely are going to upgrade your service. I'm not saying you won't, right? Let's not get into that. Or maybe it's a label
And
change.
some of it's immutable, right? Like you can't change
Oh, a good point.
some things on a service.
It's true.
You have to trade and recreate it.
There's a number of Kubernetes resources like that, right, Mark? That there's certain specs in the fields that you can't change on the fly or patch.
Yeah.
I still to this day will run into it. Right? I'll just try it and be like, oh, you try to write it and it says Kubernetes pops up and you got the error and I'm like, oh, you can't change that. And I forget which field sometimes. After you see it, often you're like, oh, that makes sense.
Right.
Because you just can't do certain things on the fly. So as we were saying, pods. are going to be IPs are ephemeral, the pods are ephemeral, and let's face it, don't run one replica, right? You're probably going to run 2 or 3. Why? Cluster upgrades. Right, let's just go to the easiest one. That means your pod will be evicted at some point, during a cordon process and drain. Evicted is probably a wrong word, but that's what it is. It's going to go to another node, it restarts. That means downtime, right? A couple seconds, hopefully, if that. But what if your containers, I'm going to be a very weird fringe container, 18 gigs. Yes, I have an 18 gig container. Yeah, it's actually Anaconda. Right, they basically took the VM of not this is the vendor, by the way. So it's big, so it takes a while to pull. Now, if you don't have replicas of that, that means it'll be unavailable for, well, whatever time your network takes in your registry, right, to do this. I am too, actually. I like that. I do like that. So if anything anybody learned today, you got a great terminology for it for SRE. And again,
I cannot claim credit for that, by the way. Yeah, I can't claim credit for that. That's something I read on some social at some point. So I cannot claim credit for coming up with that one.
Always like those things, though. So services are going to get this. Great. So how does this service, though, go to, let's just say 3 pods, 5, 10, 20? Who knows what you're running, right? So services, like everything in Kubernetes, is based on labels. Everybody is on this, if you're new, might be something you've heard only a couple times, but just remember labels, key values, that's everything in Kubernetes. So I might be running a web server front end, right? I'm going to say it's App-NGINX. You're going to create a service now. My service is going to say, cool, create the service. Anything with App-NGINX will tie back to this service. So, as we just mentioned, the service is a more static IP. This goes back to what you were saying, right, Mark? So it's there. You don't delete it, and assuming you don't rekey your IP ranges, let's not get into that conversation too, but it's going to be the same. It'll then, depending how we set this up, right, load balance. But how does it know about all those? So services link to what they call endpoints. So the endpoints are found based on the labels that match. So let's say you had 10 pods running, and we'll just say the IPs became 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Extreme. When you do a get EP or get endpoints for this, you will then see, oh, cool, it shows this list. This service is linked to these IPs. So when you go to call the IP of the service, it's going to go to one of those backends. Now this gets into service type, and this is where you were talking, Mark. So when you create a service, everybody, and maybe I should get into maybe showing part of this, right, Mark? So
yeah, I think that would be great.
Let me present and sharing my screen. Now the question is, what screen? Oh, cool. So I can pick which one's screen 2?
Remember, we're live, so.
I know that. That's why I'm being very careful. With any luck, I'll share my bottom screen. So you should see my Stark Industries, right?
Yep.
So we're going into Marble versus DC. Okay, well, we got that here. I'm going to just pop up a cluster I have here.
Go ahead and make that font a bit bigger.
Yeah, it is kind of small in this here. So it's going to scroll a little bit. What can I do, right? Apologies for everybody on the call watching this. Let's see if I go to maybe a 14.
Can't just hit like Control-Shift+ to zoom in?
I have never tried. No, it's putty.
Yeah.
So
Windows.
Is that visible?
Everybody point and laugh. Windows.
I could do something else. It's just I'm old school on this one. It's just what I've always used, and I still have it. So I'll go to a bigger one. It's obviously going to, wrap is going to be the one issue. So is that kind of visible?
Yeah, I can see that. You might also want to do that whole export PS1 equals.
Oh yeah, the nice little tidbit we got from last week. Do you have that command handy, Mark?
Yep, I just sent it to you in the private chat.
Awesome. Okay. Yep. Yeah, I love that tidbit. I actually got to remember that some. Cool.
Yeah.
Okay. So what I'm going to do in this example is get a service, right? So this is just my default namespace, and this happens to be the one that comes with all Kubernetes clusters at this point, right? There's always this one made that's Kubernetes, right? Now, so you can hit the API server internally through the cluster. It's a static name. It's there, always available. Awesome. We're going to edit this though, right? And I'm going to be lazy since we only have one service. I'm not even going to give it a name. Now there's a lot in here because it's been deployed, but we're going to talk about that type. Okay, so we got the type of cluster IP. And this is going to be the most common one you see, right? And we do go through these in the chapter. You'll actually see a little creating services section where we say cluster IP, node port, load balancer, external name. So let me pull that up. And so cluster IP is there. It's going to make it accessible within the cluster. It is a default type. So if you don't specify a type in your manifest, it's going to create a cluster IP. Right? But as Mark was mentioning earlier, if you wanted to have something that's accessible directly on the network, you would change that type to load balancer. It's not uncommon for new Kubernetes people to try this because you'll see this in examples everywhere. Use load balancer, it's accessible externally. So you try it and you never get an IP, right? It sits there pending. And that's because you need to deploy a component like MetalLB. Doesn't have to be, right? People like Google, Amazon, they can connect something, say like, I'm gonna say their services, traffic directory or something where you got to integrate it somehow, right? In our case, we'll use MetalLB. We'll probably wind up showing that next week. The other types, node port. I love node port for troubleshooting, right? That's about it though. Never use node port in production. People do. There's a reason you don't want to though. So if we were to just pull this down again, node port. So node port's going to grab a random port above 32,000 something. You can then access your service by targeting any node name in the cluster. So let's just say you called it node 1, node 2, node 3, node 4. Actually, in my example, let's just look at my nodes. So I've got node 2 or node 1, node 2, node 3, and one control plane. Truth be told, this is not a kind cluster. There's a reason for it. I'm using this cluster for some other testing, and I actually needed to have a full Ubuntu for what I'm testing. So this is why you don't like to use node port. It's not that node ports are bad, but you might deploy a client to 1,000 people, right? And it's your application, and you decide you're going to use node 1, as your target because you got to put something in there. And the port. Well, what happens when node 1 goes down? Worse than that, what if your cluster upgrade and during the upgrade you have a node pool and one IP? Anthos works like this. So one IP is going to be dropped at some point and one added. You don't know what node that's going to be. What if node 1 is the one that during the new creation doesn't get created? Your app goes down. So why would I use node port? The one thing I love using node port for troubleshooting is you get that call from a developer or a user, customer, or whatever it might be. And they're going to blame Ingress. My app's not working. Ingress is the problem. I'm like, yeah, I don't think it is. Okay, well, rather than get into that discussion, put on node port on there, hit it by node port. If it still doesn't work, you're bypassing Ingress, right? I can now say, sorry, you're basically going from client to node to another node, most likely as kuproxy. But if that works, okay, maybe it is the Ingress controller or the Ingress rule, right? Bad annotation or something. So I like node port for that. It kind of stops that fighting. Fortunately, like you were saying, Mark, you can change the type on the fly. So under services, I could say, oh, it was cluster IP. Let's make it node port. You got to delete a couple other specs in there, but again, we won't get into that too much. And that last one, some people might not even know it exists. External name. I have an example in here I use for it. It's the best one I could come up with on the fly when I was writing the chapter. You can basically put a name in there and point it to, let's just, my example, I use an external SQL server. And it'll resolve, so internally your pod's going to find that external name, and it can go over to it. Now you might say, why don't I use DNS? That's in the book. I don't really want to dwell on the external part, because there's one thing I really want to show that's come up in some conversations recently with people. So now DNS, we talked about a little bit. There's pods out there, right? So your pod does get an IP, but it doesn't register that pod name with core DNS. I'm going to say the Kubernetes DNS service in this case. So hopefully my screen's still there, right? So of course all the clusters in, usually in kube system are running something like core DNS. So your pods come up, your services come up. Now services will register with a name. I should have, let's see if I still have it running. Yep. So I'm a big fan of this NetShoot, right? Everybody, it's a great troubleshooting container. It'll also raise some incredibly major red flags if you've got some massive runtime security and your security team sees it running because of the tools that are in it. So that's a good thing, right? So I need it for this kind of testing. I am currently in the directory where I'm going to deploy Kafka. So I am going to...
Something that's small, lightweight.
Yeah, nothing major. It also gets way over my head quickly. Not a Kafka expert. So in this case, I'm creating a stateful set for Kafka. And now the stateful set is going to be a key point in this discussion as we talk about this. So if I do my git pods for Kafka, it's going to take a little while, so it's doing the stateful set. I am going to look at the services now in Kafka. I have two services on purpose. I need one, but I did two for this example. You're going to notice in this list, I've got Kafka service and Kafka something called headless. Now, headless is still, you're going to hear people say headless service. It's still a cluster IP service, right? It's not its own type. But let's look at my stateful set.
I was going to say, because your cluster IP is actually none.
It is. Yeah, absolutely. Good eye on that, Mark. So there's a reason for that. Oh, I don't deploy them in this one. My apologies. I actually did create two separate ones. So this is actually the example service you'll get with the Kafka deployment. And as Mark kind of pointed out here, by the way, not rehearsed at all, Mark called out, you've got no IP. Well, what I did here is this is how you make a headless service. You set your cluster IP to none, right? Now, it's still a cluster IP type, but you're setting it to no IP. This creates a headless service. Now, there is going to be a specific reason why we do this, right? And again, I like bringing this up because I've actually run into it in production and questions from real world developers twice this week. Once with a vendor, by the way, that went interesting. It was an interesting discussion where I was being told I was wrong, and I had to show it. So this is the one I don't need, but I create this to show you a regular cluster IP, right? So in this case, you'll notice I don't have to set the cluster IP to none because I want it to get an IP. Okay, so sorry, keep going on this. Let's see, the pods are ready. Pods are ready. That's a key point for what I want to show. So I want to show, I'm going to exec in the NetShoot container. Again, big shout out to the creator of that thing because it's just awesome. So I'm now in my temporary shell. So in the Kafka example, we said pods don't create IPs. Now Kafka Mongo. A lot of these, I'm going to say complex installations. Kafka is an example. It needs to know where certain parts of the application are running. Best wording I can come up with. Let's call it the primary. Right now, I have to somehow link to that. How am I going to do that, though? We just said pods don't get a name, right, in DNS, not with a normal cluster IP. So, again, I'm trying to remember what I named them. I think I did this correctly, but let's take a look. We're going to look up the services, right? We said services get a name. So I should have a Kafka, I think I've got just Kafka service. I do. So this Kafka service, I can tell you right away which one this is. This is the one that is a cluster IP that's getting an IP. It's not headless. So this is resolving to 1099, 49, 19. Cool, that's what I expect. Just to prove that there is, no trickery here, because maybe you don't believe me. And there's that IP, right? So this can be queried anywhere in the cluster. Obviously, if you're outside the namespace, you're going to have to make sure you put in, the namespace in there. But I'm going to go back into execing. So again, there's that service. Now it's going back to 3 pods. I'm going to exit yet again. I'm going to demonstrate my endpoints. I mentioned this before getting into this. So we can see that here's my Kafka service. It knows that all 3 of those pods have the right labels. So one IP could go between all 3 in a round-robin fashion by default. Yes, you can change that as well. That could be bad for Kafka. I need to know the primary. I can't do that using that service because it's going to hit randomly based on round-robin, one of those 3. I can't do that. Kafka will not work. Kafka needs to know where things are. Notice the headless service, though. Looks the same, doesn't it? Still labels. It's still going to Kafka. But here's the special magic. And again, things that have come up this week. Let's look at that service again. We called that one Kafka headless. Okay, now I'm going to explain why this happens. There should be 3 IPs. The reason there isn't is one of those pods is failing. So I got to look at the Kafka deployment. That's why I do it on the fly real quick, so I can say, okay, cool, they're all there. But notice that now one's back because it's probably in a crash loop. So this has now said you've got 3. That's awesome. But notice the name. Say, well, how does that help me? Say we're configuring Kafka, and Kafka 2 was the one you wanted to know about. How do you find that IP? Headless services will actually add a DNS entry for the pod. So in this case, it's Kafka 0. So I am going to try to ping the pod name now with the service, which is headless, and of course the namespace. Why the namespace? Because I'm running in default for this. I have to tell it what namespace to go look at. Notice Kafka 0 says, yep, you're running on 147. Kafka 1, assuming the pod's up, 244. Kafka 2, 288. Now, again, to prove a point, as Mark would always say, nothing up my sleeve, right? Let's prove this. So let's get our pods wide so we can actually see IPs. You will see 88, 244, 147. They all match over here. So there are reasons you want to target an actual pod directly. But in this case, the pod name's never going to change because the stateful set will always bring it up with Kafka 0, Kafka 1, Kafka 2, Kafka whatever down the line, right? And you just got to put it in front. Now this is a headless service. So it's not uncommon for people in Kafka to do a headless and a normal cluster IP for certain operations. So you might actually see this in some pretty big deployments, especially in the enterprise world, where you might say, why are there two? Why do they make a headless? Why is there no IP? You want the IPs, you want the names. That's pretty much why you do this. You simply want to. Now, there are other fringe use cases for this. You can make your own custom load balancing, for an example, right? Because you can say, oh, cool, I'm always going to hit one first or something weird like that. It's common, like I said, in Kafka. I think Redis has portions like this too. Again, I'm not a Redis expert. But when you see stateful set, that's one of those reasons to use one. It's a great interview question, by the way. If you ever ask somebody, because you say, why would you use a stateful set? A common, I'm going to say incorrect answer is you want storage. You can do that, of course, but you don't need it. But you want controlled naming. You want controlled startup shutdown. And if that person's really good, they're going to tell you, and I can do naming by DNS. So anybody that's newer, you're going to interview, mention that on an interview when they say stateful set. So yeah, if you do a headless service, the pod gets a DNS name. Sorry, that's a long explanation for it, but I absolutely loved when this came up in an actual question in the real world.
Yeah, no, that's I actually don't think I knew that. I think that that would be something I would have liked to have known a little while ago, doing some work. So, I love learning something new. Again, I know enough about networking to be dangerous. We're coming up.
I like to call that out, by the way, Mark, to everybody on this call again, where people will often say, and I'm sure you get this too, Mark, right? They're going to say, well, Scott knows that. He's been doing it a long time. No, I learn something new every day. I really do. This one, yes, I knew, but there's so many times. So don't ever get frustrated. I know we had somebody calling out newbie, right? That's great. But don't ever sit there and go, wow, Mark, myself, anybody that's been in here a while, they just know this. No, I do, right? But I learn something all the time. That's why I love it.
Right.
So I'm sorry, Mark, go ahead.
No, I was going to say, we're coming up on top of the hour. We haven't actually hit any of the labs in the chapter.
But this is a good overview.
So, I think we'll do a continuation next week of this chapter where we'll dive into the labs.
Well, this is a great basis, because when we do deploy some of these, we don't necessarily have to now say the service is pointing to this endpoint.
Right.
We've already been through what that is.
It's a complex topic. I mean, it's one of those things that it's like anything else in Kubernetes. It's deceptively complex. It seems so simple, in an era where everything is DHCP and just starts up, it has an IP address. You just hit it. It is deceptively simple. So I actually think we lost our LinkedIn integration, so I apologize. But I do know that one last question that kind of came in here, I think it was from Boris as well, is there some sort of WAF with the load balancer and K8s? I would say that because most Ingress controllers are just web servers, and most web servers in 2025 have some kind of WAF capability, the answer is probably yes. From a practical implementation standpoint.
Mark, there's open source projects.
Oh, sorry, Scott. Go ahead. I think you're going to say the same thing I am, but why don't you go ahead?
Yeah, there's open source projects for WAF, right? There's some potential in normal load balancers, but we at my place we do this, right? We have WAF from F5 that gets added, right? To SQL injections, cross sites, everything like that. But most of the MetalLB is an example, right? I'm going to say it's a dumb layer 4, and I don't mean that in a negative way. I'm simply saying that's its job. Give me the IP, know what VIP, the VIP goes to these real IPs, and that's it. There's no intelligence in it. Now, some do, like you were saying, Mark, but a lot of the other ones I see in Kubernetes typically don't. There's add-ons.
Yeah, and I think that's something you want to do a little higher, right? I mean, WAFs are not just turn it on and have fun, right? Like there's often a lot of oh, this URL, no, this really isn't a attack, or this is uh, this pattern is fine. Go with it, right? Um, so WAFs are not one of those things that you throw on and you call it an afternoon. So, while you could use the Nginx, I think Nginx uses like mod security.
Yeah, it has some.
Proxy has one. I'm sure there are half a dozen for Envoy with Envoy filters. Um, I would personally say implement it at a higher level. Like, don't implement it at the Kubernetes ingress level.
Well, and a lot of them, they implement different ways. Some have sidecars, right? Some do funnel it through another pod running. And quickly on the one, Kafka over here said I could have leveraged WSL. Absolutely. Yeah. Yep.
Yeah. And I'll pile on here. PowerShell now has SSH.
Yeah. So I do use Windows Terminal as well, but I have a lot of sessions created in PuTTY and they go in the registry by default.
Yeah.
And I'm like, I have to just export this stuff one day. And I have a lot of SSH authentication. I'm like, pure laziness. I'm going to be honest, right? They always say that, right? A person that's a carpenter, you go to their house, it's probably the worst carpentry you'll ever see because they did it all day. Well, I do all my correct during the day, my day job. So my stuff at home, I probably could use a little bit more cleanup.
Yeah. So we're not going to go past the hour. So why don't we just plan on coming back to this? Because especially when we get that MetalLB, that's one that I think a lot of people are going to really appreciate, spend a little time on. So we'll make this a 2-week chapter. And then, so next week when we come back, we covered a lot of the fundamentals this week and the foundational of what we talk about in the book. And I answered some really great questions. I think next week we're going to just dive right into it. Start with the lab, start off with the ingress, and kind of plow through from there.
Absolutely. Yep. We'll talk about the traffic flows a little bit more, but this would be a fundamental, almost like 101 to get into that topic.
Yeah. So, hey, everybody who came, thank you for coming. If you have purchased the book, thank you. If you have a spare moment and you could leave a review on Amazon, we would be greatly appreciative, as long as you enjoyed the book. If you didn't like the book, find a different book and leave a review. But
I leave the groveling to Mark. I'm all good with it.
I sell software for a living. I got no problem groveling. So go ahead and leave a review. It'd be very much appreciated. It makes a really big difference, especially if you bought the book on Amazon. Those reviews really help us stay at the top of the list. And I think if you haven't bought the book, they discounted it again. Over Christmas it was like $30. Now I think it's like $40 for the Dead Tree version. Then you get a free version of the ebook with it. So please leave a little review. Hey, we loved it. It doesn't need to be an essay. It does make a huge difference. But I think we are back at the top. If you search Kubernetes on Amazon, I think we're back on the first one that comes up.
And we appreciate all that support, obviously, right, Mark, from everybody. And I joke with people, you don't get rich off books. That's not what we're here for.
No.
It's great to write. It's great for us. We like helping. We like the feedback too, right? To everybody, tell us other topics as we're developing the next edition. It's like, cool. What do people want to see? Obviously, that's a long time away. We just published a couple months ago.
No, we're not doing another edition anytime soon here, Scott. So anyway, thank you everybody for coming. Thank you, Scott, as always, and enjoy the rest of your week, y'all.
Thank you to everybody. Thanks, Mark.